So I've been thinking about something. We spend about 60% of our lives between the ages of 1 to 18 going to school, doing largely the same thing, which is essentially studying and learning.
The students are having a lesson.
We are taught loads of different subjects by our teachers, then we are assessed on them using tests.
A star to G grades.
And this is what our current education system looks like. The classroom of the 1950s
disturbing the class.
looks almost identical to the classroom of 2020. So the education system has been the same for decades. We've gone to school for more than a decade. It's interesting then that one of the first questions that students have when they're about to start university is, how do I study effectively? And although we are taught loads and loads of different subjects at school, we never really learn how to learn. And this is the question that I want to address in this video today. And the first thing I'm going to say is, I didn't really do it the traditional way, but we'll get onto that a bit later. I'm going to show you some of my work and notes from the last 6 years of medical school and how I've been approaching learning and how it's changed over the years. Now, in order to understand how to approach learning, we need to understand the problem. And there are two main problems. Number one, there's an outdated teaching style. And this is the lecture style that we all know of. I mean, just think about it. You've got 300 students and one lecturer. You've got 300 students, all who think in different ways, process things at different speeds, but you have one lecturer who says things in one way. How does that even add up? Often in my lectures, I'd find myself sitting there, I'd miss one point early on in the lecture and just lose focus. I would just think about the specific point that I just could not understand, and I'd spend time searching things, and then I'll be behind within the lecture, and that's it. I've lost focus, I fall asleep. Problem number two, there's a lack of clarity. We simply do not know what we need to know and what we don't need to know. And that's probably because university is branded like this place where there is no limits to learning, where you're supposed to develop lateral thinking. So you go in and end up thinking, you know what, I should be learning everything, I should be reading everything that comes my way. And you quickly realize that understanding a topic and scoring highly in exams are two very different things and two very different skills. So basically what I ended up doing in order to overcome this was quite unorthodox, and that was just, I stopped turning up. Now I have to say that all of our lectures were audio recorded, and when I found this out, I asked myself, you know what, why should I attend the lectures when I can play back the audio recording at 1.5 times speed? I could pause and search things up, I can replay bits that I didn't hear properly. For me, that was just a no-brainer. So for the following years of my university career, whenever a lecture was not compulsory to attend and it was recorded, I just did it in my own time in the library at my own pace. So I would say, if you have this option available, and I think this happens at most universities, at least in the UK, try it out for a week and see what you think. So how do we deal with the lack of clarity? What I've come to understand is that the role of a university is to get all of their students to an ideal standard. And that ideal standard is the curriculum. It's essentially the ABC of exactly what the university wants you to know by the time you graduate. Anything beyond that is a bonus. Anything less might lead to a lower grade. Now, they don't really spell this out to their students, and I didn't really understand this either before I started university. But it was towards the middle of my first year where I came to a realization that completely changed my thoughts on the way I should be approaching learning. I realized that the questions that we get in our exams are directly made from the lecture PowerPoints by the very same lecturer who made those PowerPoints and who gave the lecture. Now you might think, duh, like that's not anything revolutionary you're telling us here. But bear with me. In the UK, when we're in high school, every single student sits standardized exams that we call GCSEs and A-levels. So we go to school and our teachers teach us content that they think is important and that they think will come up in the exam. But the point here is that those teachers never wrote the questions in those standardized exams. They're usually written by an exam board. And this was completely different from my university experience, where essentially they look at the slides and they say, slide 2, let's make a question out of that, and that becomes a question. So for example, in my first year, we had a lecture that covered the cytoskeleton of cells. And in one of the slides, it listed out the function of different types of cytoskeleton. So the function of intermediate filament, the function of microtubules. And then I went into the exam, and lo and behold, one of the questions said, name the function of microtubules, 2 marks or 3 marks or whatever it was. And from this, I was able to derive 2 rules. Number 1, everything you need to know in order to excel in exams is found in the content taught. Number 2, you will not specifically be tested on things that have not been taught in the content. In the later years, there is a research aspect that you need to demonstrate, but that's for a different type of video. And it was here, based on these rules, that I then developed my university studying strategy. And I can divide this strategy into 3 simple steps: accumulation, conceptual understanding, memorization. The accumulation stage is where I would take all of the information from the taught content into one folder, essentially note making. I found that the information from the slides could be condensed into much simpler and standardized format. I mean, sometimes we'd have lectures with over 70 to 80 slides, and in that format, the information is way too scattered in order to learn effectively from. That means that, you've got 70 items to memorize. Instead, you can just take that into a Word document that is 7 pages, and that's 7 items in your mind that you need to memorize. It's just a bit easier. I would have one big folder for the semester, and within that, I would have folders for each topic taught within that semester. So for example, in the cardiovascular folder, I'd have all the lectures that were taught as part of the cardiovascular topic. And the notes in this folder would be based on the lecture slides and the lecture recordings. Now let's take an example. There was a lecture that we had on the cardiac cycle. If you look at that lecture, point number 1 and point number 2 discuss diffusion and convection, and this came directly from the slides. Now point number 3 wasn't something that was in the lecture slides, it was mentioned in the lecture recording, and I thought it was important, so I also added that into the notes. And I did this for every lecture, every seminar, every tutorial, until I was satisfied that within this semester folder, I had all of the information that the university wanted me to know for this exam. Everything I needed to know in order to do well in my exam was in this folder. And that's the only time I felt like I could comfortably move on. On a side note, the reason why this particular strategy worked for me was because the lectures are often linked. They're a series. So for example, you might derive one particular understanding of lecture number 1, but then you have a series of other lectures that changes your understanding of lecture number 1. And so there's no point trying to memorize lecture 1 when you've just started it, when your understanding of it is going to change later down the line anyway. And that's why I left memorization to the very end after I'd covered this and understood this. Step number 2 is conceptual understanding. Although I'm mentioning this as its own step, it would usually happen simultaneously to step 1. So as I'm accumulating the information, I would also try to understand it. And this is essentially where I would try to apply some critical thinking and figure out how are the different lectures linked together to eventually have that light bulb moment where you feel like all of the pieces are finally falling into place. Let me give you an example. Let's go back to the cardiac lectures that we used to have and give an example of conceptual understanding. You might have one lecture which discusses blood flow, mentioning that one of the most important factors in blood flow is the radius of the blood vessel, or how narrow or big that blood vessel is. And then you have another lecture which discusses what is it that affects the radius of a blood vessel, and you learn that blood vessels have little bits of muscle which are known as smooth muscle, and that smooth muscle can contract and relax, leading to narrowing of the blood vessel and dilation of the blood vessel. And then you might have another lecture where you learn that actually these blood vessels have receptors, and the activation of these receptors directly leads to the contraction and relaxation of that smooth muscle. And then you might have another lecture which discusses those receptors in detail. What are those receptors made of? How many subunits do they have? You learn that they are called alpha and beta receptors. You learn that they have different pathways and mechanisms like the cyclic AMP pathway, the PIP2 pathway, and you learn that they're also called adrenergic receptors. And then you might ask, why are they called adrenergic receptors? And you learn in a different lecture that these receptors bind something called called adrenaline and noradrenaline. And that adrenaline and noradrenaline are part of the sympathetic nervous system. And then that goes into a completely different lecture and a different whole, which discusses the sympathetic and the parasympathetic pathways and the stress response and the fight and flight response. And when you can link lectures together like this is when you're starting to grasp that conceptual understanding. Now that you've got the understanding down, it is time to memorize this understanding, but also learn the small details. See, you might have the overall understanding that all of these are known as adrenergic receptors. If asked a specific question about an alpha-1 receptor, you might not be able to recite the GQ pathway for the alpha-1 receptor, and that's where you're going to get the marks. And this is how you see that the conceptual understanding is different from scoring highly in exams. So you move on to memorizing this, and I've talked about memorization loads in another video, but if you want me to go into more detail, then let me know. But I will link the video below, and it talks about how I memorize loads of different things very quickly. There's no point of me going over that in this video. So overall, those are the 3 steps: accumulation, conceptual understanding, memorization. And following that feedback loop then hopefully should lead to effective learning in school and university and whatever. I hope you like this video. If you like this video, then like the video, comment, like, subscribe. Safe.